Example 1, when 80% of a number is added to the number, the result is 252. What is the number? So what we want to do is we want to write an equation, and we want to solve that equation, and the answer to that equation, the solution, should be the answer to the question that we are being asked. What is the number? So to come up with the equation, let's translate from English to math. 80% is 0.8. Of, in math, means multiplication. A number, well, let's let that be n for number. You could use your any variable would be fine, x, y, doesn't matter. Is added to, that's plus, addition, is added to the number, so the number we said was n. The result is, that's an equal sign, 252. What is the number? That means find n. So translating from English to math, we have 0.8n plus n equals 252. Find n. Now on the left-hand side, we have 0.8n's plus 1n. That leaves us with a total of 1.8n's on the left. So we have 1.8n equals 252. Dividing both sides by 1.8 leaves me with n equals 140. So what is the number? The number is 140. I want to point out that using the guess and check method to solve this will not get you full credit. Part of this objective is coming up with the equation and solving the equation for the number. Example 2. The length of a rectangular pool is 6 meters less than twice the width. If the pool's perimeter is 126 meters, what are its dimensions? Again, we're going to create some equations using algebra, and we'll solve them to answer the question, but first let's translate from English to math. Length, we'll have that be L, the variable L, so I'm defining that variable, of a rectangular pool is 6 meters less than is minus twice the width. Let's let twice the width be 2w. So I want to look at, so we have the length of a rectangular pool is, that's equal 6 minus 2w. So I want to consider L equals 6 minus 2w, or L equals 2w minus 6. So I want to look at both of those statements, and only one of them reads the length of a rectangular pool is 6 meters less than twice the width. So 6 meters less than twice the width is L equals 2w minus 6. So when we have subtraction, I have to take a step back and consider the order of the terms, because with subtraction, order matters. So I know that L equals 2w minus 6. I also know that the pool's perimeter, P, is 126. What are its dimensions? That means find the length L and width W. All right, so let's write down what we know. We know that the length is 2w minus 6. L is 2w minus 6. We know that the pool's perimeter is 126, and this is all in meters. Now, I know something about a rectangle, so one side of a rectangle, this one at least, is going to be 2w minus 6, the other one is 2w minus 6, and then one width is w and the other width is w. So the perimeter of that rectangle is the sum of all of those sides. So if I add 2w minus 6 plus another 2w minus 6, now the sides plus a w and another w, that combines to give me, okay, I have 2 W's plus another 2 W's plus another 2 W's. That's a total of 6 W's. And then a -6 and a -6 gives me -12. Okay, so I know that the perimeter also equals 6W minus 12. Now I know two things about the perimeter. I know that the perimeter is 126 and that the perimeter equals 6W minus 12. So if I combine those two statements, I get 6W minus 12 equals 126. I like that statement because it only has one variable in it, W. I can solve that equation for W, and that's what I'm going to do. So I'm going to add 12 to both sides. That gives me 6W equals 138. Dividing both sides now by 6, I solve for W, and W equals 23. So the question was find the length and width. Well, there's part of the answer. The width is 23 meters. So now let's find the length. We need the relationship between length and width is given to us in the equation L equals 2W minus 6. So if I let W equal 23, then I get L equals 2 times 23 plus 6. So therefore the length is, so 2 times 23 plus 6 gives me 40. So the length is 40 meters. So what are its dimensions? Well, 23 meters by 40 meters. Example 3. You invest $12,000 into two stocks. One stock paid 14% and the other lost 6%. The total income from both combined was $680. How much was invested in each stock? All right, so we invest $12,000 into two stocks. One stock paid 14% and the other lost 6%. So 14% as a decimal is 0.14 and 6% as a decimal is 0.06. So I don't know how much of the 12,000 went into each account. That's actually what we have to, that's what the question's asking us to find. So for example, if $2,000 went into the 14% account, then that would mean that $10,000 goes into the 6% account. If $6,000 goes into the 14% account, then $6,000 would go into the 6% account. So whatever goes into the 14% account, the remaining amount of the $12,000 will go into the other account. So if I put X dollars into the 14% account, then the difference between 12,000 and X must go into the other account. Now we made money on the 14% account, but we lost money on the 6% account. So that 6% needs to have a negative in front of it. Combined, they total $680. So I want to write an equation involving X, and I want to solve it in such a way that that will help answer the question being asked, how much was invested in each stock. So here's how I do that. I take how much money goes into an account and I multiply it by the decimal percentage rate. And I do that for each one. So I take 12,000 minus X and I multiply it by 0.06. And that leaves me with this equation. 0.14X minus 0.06 times the quantity, 12,000 minus X equals 680. So somehow you need to create an equation involving X. So we're going to solve that now for x. So to solve that for x, I'm going to distribute the negative 0.06. So that leaves me with 0.14x minus 720 plus 0.06x equals 680. Okay, well, I can combine like terms on the left. If I have 0.14x's and I add 0.06x's, that gives me 0.2x minus 720 equals 680. So adding 720 to both sides gives me 0.2x equals 1400. Dividing both sides by 0.2 gives me x equals 7,000. Now that's not my final answer, but that will help me answer the question. So x is 7,000. When I first created this problem, I assigned x to the 14% account. So that means that $7,000 goes into the 14% account. And we started with 12,000, and if we put 7,000 into the 14% account, then the remaining amount which is 12,000 minus x, so that's 12,000 minus the 7,000 is 5,000. So the remaining amount is 5,000, and that's what goes into the 6% account. So my answer is that $7,000 went into the 14% account and $5,000 goes into the 6% account. Example 4. Solve s equals 2 pi rh plus 2 pi r squared for h. So I in the prize, I'm solving for h. So I notice that I have two terms on the right, only one of them has an h in it. So I'm going to move the term that does not have an h in it to the other side. So that means I'm going to subtract 2 pi r squared to the other side. So that gives me, and on the left, it's a little, it looks a little confusing because I have to somehow combine s and a negative 2 pi r squared, but they're not like terms, so I can't combine them. The best I can do is write them side by side. S minus 2 pi r squared equals 2 pi rh. Okay. I in the prize. I'm solving for h, and I see that h is being multiplied by a 2, a pi, and an r. So the opposite operation of multiplication is division. So I'm going to divide out by what I don't want. So I'm going to divide both sides by 2 pi r. So that leaves me with s minus 2 pi r squared all over 2 pi r, and that's what equals h. And I want to point out that that can be your final answer. Now many of you will want to try to cancel the 2's and the pi's and some of the r's. Here's why you can't do that, or if you wanted to, here's how you would properly divide them. So again, that can be your final answer, but let's just note that if you wanted to simplify that further, you could break it up into two pieces. So the s needs to get divided by 2 pi r, and then the 2 pi r squared should also get divided by 2 pi r, and we subtract. That's what h equals. So now only in one of those fractions can I cancel. The 2's cancel, the pi's cancel, one of the r's in the denominator cancels with one of the r's in the numerator, leaving me with So the first term is s divided by 2 pi r minus r. So that's two ways of writing the same thing. Example 5. Solve a equals 1/2 h times the quantity a plus b for b. All right, I and the prize, we're solving for b. And I should say that one of those a's is a capital H and one is a lowercase. So we have big A equals 1/2 h times the quantity little a plus b. All right, so the first thing I notice is that 1/2. Let's get rid of that 1/2 by clearing fractions. So the LCD is 2. So I'm going to multiply both sides by 2. Now, there's one term on the left and one term on the right. Some of you might think that there's two terms on the right because of that plus sign, but the A and the B are actually tied together with the 1/2 h before it. So there is only one term on the right-hand side. So if we multiply both terms by 2, the LCD, then we're left with 2 times big A equals, now those 2's cancel out, so I'm just left with on the right-hand side, h times the quantity little a plus b. All right, I and the prize, we're solving for b. Now, about half of you will want to distribute that h, and about half of you will want to divide by h. So I'm going to solve this both ways because both moves are equally valid. I'm going to solve it both ways to show you that it's the same thing. So I'm going to write or 2 times big A equals h times the quantity little a plus b on the right, and we'll solve that one on the right in a moment. But for right now, let's distribute h. So I have 2 times big A equals h times little a plus h times b. All right, I and the prize, we're solving for b. I notice that one of the terms on the right does not have an h in it, so let's move it to the left-hand side by subtracting ha from both sides, which can be a little bit unusual, or it might feel a little unusual because subtracting 2a and ha is kind of tricky, and it's good that it's tricky, it's because it's impossible. They're not like terms, so the best we can do is just write them side by side. 2 times big A minus h little a equals h times b. All right, I and the prize, solving for b, I'm going to just divide by h, and that leaves me with h equals 2 times big A minus h times little a divided by h. Now, some of you might want to divide those h's out, but you can't do that because remember, the proper way to cancel or simplify would be to rewrite that in two terms. So the 2a, big A, so the 2 times big A needs to get divided by h, and then the ha needs to get divided by h, and we subtract. So now I can divide the fraction on the right, ha divided by h. I can divide each by h, canceling the h's, and that leaves me with h equals 2 times big A divided by h minus a. So either one of those answers is fine. You don't need to, the last one, 2 times big A divided by h minus a, you don't have to take that last step unless you wanted to. Now let's go back and let's see what this would look like if we did not distribute that h, if instead we divided both sides by h. So I now have 2 times big A divided by h equals the quantity a plus b. Well, I and the prize, we're solving for b, so I need to move that a to the other side, so I'm going to subtract both sides by a. Now, on the left-hand side, those are not like terms, so the best I can do is write them side by side. So I have 2 times big A divided by h minus little a, and that's what b equals. And we notice that these last two solutions are the same. Example 6. Solve the equation 1 divided by a plus 1 divided by b equals 1 divided by c for a. All right, so we have an a, a b, and a c in the denominator. So let's clear fractions. I notice that the LCD of a, b, and c is a, b, c. So I'm going to multiply all three terms by ABC. I'm going to put an ABC in the numerator. Now 1 times ABC is just ABC. So this leaves me with ABC divided by A plus ABC divided by B equals ABC divided by C, which looks like a mess, except that watch how it cancels. All the denominators cancel out, which is the purpose of clearing fractions. So what I'm left with is BC plus AC equals AB. All right, eye on the prize. We are solving for A. And I notice that I have two terms with A on them, and they are not on the same side. So I'm going to move the AC over to the right-hand side. So I'm going to be collecting all of my terms with A's on them on the right-hand side of the equal sign. So to do that, I'm going to subtract AC from both sides, leaving me with BC equals. Now again, on the right-hand side, it might look a little tricky to combine those, which it should, because you can't combine them. They're not like terms. The best we can do is write them side by side. So I now have BC equals AB minus AC. So both terms on the right-hand side have an A on them, and the term on the left does not have an A on it. So I'm solving for A, and A is in two different terms. So what I want to do is factor out the A from the right-hand side. So if I factor out an A from the right-hand side, I'm left with B minus C. So that gives me an equation of BC equals A times the quantity B minus C. Eye on the prize, solving for A. I notice that there's multiplication happening between the A and the parentheses, so opposite of that is division. I'm going to divide out by what I don't want, which is B minus C. And that leaves me with A equals BC divided by the quantity B minus C, and I don't need to do anything else to simplify that.